This is group 5 and this is our project problem. Our question states the figure below shows a Ferris wheel at an amusement park. The wheel has a radius of 40 feet and the center of the wheel is 45 feet above the floor. The wheel makes one full rotation in 40 seconds. Part A says let h of t be the vertical distance between the point P and the floor at the time t. Express the function h as AV. You may assume that at t equals 0, the point P is at the lowest point in its travel.
To begin, we have to find the height of the point P as a function of time. As stated in the problem statement, the point P is rotating around A at a distance of 40 feet with the speed of one rotation per 40 seconds. The point A has an altitude of 45 feet. In order to make it easy to understand, we will first show the evolution of the height of P as a function of time graphically. So we draw the graph when t equal to 0 and P starts from the lowest point. Next, since the height from the ground to the center is 45 feet and the radius of the circle is 40 feet, the height from the ground to the lowest point of the circle is 5 feet, as shown on the circle. In addition to that, the highest point on the circle will be 85 feet. Next, we graph the time we found with the height that it is on the Ferris wheel. Recall that the graph of the cosine starts from 1 because if we look at the unit circle, we can find cosine 0, which is equal to 1, and so on. If we want to find cosine 90, which is pi over 2, we will get 0. After we find the points, we plug these points on the graph and we will get the graph of cosine x. From the previous graph, we can notice that the cosine function is repeating on x-axis every 2 pi. The period on the cosine function is 2 pi. Similarly, with the graph of our function, its period is 40. We get the number 40 because the Ferris wheel makes one full rotation in 40 seconds. So the new period for our new function is 2 pi over 40, which is equal to pi over 20. Now we have this function so far, 40 cosine pi over 20 to pi t. This graph describes the function h without taking consideration of the height of A. Now the center A is above the ground and has an altitude of 45 feet, which is the height of the function h. So we will shift the graph 45 feet up, shift it up.
For part B, it states the support struts A, B, and AC are each 50 feet long. Find the distance between B and C.
So the first thing we did was we labeled the triangle A, B, and C. We cut the triangle that was made by A, B, and C down the center to now have D. Point D is the midpoint between B and C. Because this is an isosceles triangle, we can't do Pythagorean's theorem, hence why we had to cut it in half. So A, B, and D are going to be the left side of the triangle, and A, D, and C are going to be the right side of the triangle. We know that A and B are both 50 feet long, and the height of the triangle, which is AD, is going to be 45 feet, because that is the length from the center to the ground. So in order to do Pythagorean's theorem, we're going to do AC squared equals AD squared plus CD squared. AC squared is going to be 50 squared, AD is going to be 45 squared, and CD squared is going to be just CD, because that's what we're looking for. So 50 squared is 2,500, 45 squared is 2,025 plus CD squared. So if we subtract 2,025 from 2,500, that's going to give us 475 equals CD squared. If we square root both sides, CD is going to give us plus or minus 5 square roots of 19, but it's a length, so it has to be positive. And we know that DC and BD are the same because it's an isosceles triangle. All we do is cut it in half. So if we add both sides, which will be BD equals 5 square roots of 19 and DC equals 5 root 19, we can add those together and we will get BC, which is 10 root 19.
You don't want to listen to yourself?
Nope.
You don't want to listen to yourself?
Nope.